Very good afternoon. A very good afternoon, all of you. My name is Banojini Nayak, and today I'm going to present one of the hot topics, that is database architecture. So today we'll be briefly discussing on what is database, evolution of data architecture, monolithic versus database approach, core principles of database architecture, logical view, key advantages of database. Then we will conclude. So what is database? A database is an architectural framework that solves advanced data uh, security challenges through distributed, decentralized ownership. It's an architecture where data is owned and managed by the business teams. A database decentralizes the ownership to business domains such as finance, marketing, sales, and provides them a self-serve data platform and federated computational governance. This allows different domains to develop, deploy, and operate data services more autonomously and model their database based on the specific needs, while also ensuring a consistent and unified data experience across the organization. Here is how Deloitte defines it. Database concept is a democratized approach of managing data where different business domains operationalize their own data backed by a central and self-service infrastructure. Moving on, this page shows the evolution of data architecture. Here we can see how the data architecture has evolved through the 1980s through to 2021. We can see from the screen that in 1980s we were using the data warehouse concepts came, and we were using it until late 2000s, and in late 2000 the data lake in concept came in, and after that 2010 cloud data platform got introduced in the market. Similarly, in 2020 data lakehouse concept got introduced and we started using data lakehouse. In 2021 we got data mesh. So we can see from the diagram, data mesh is different from the previous uh, data architecture by being decentralized, whereas all other data architecture were centralized. Moving ahead, here comes monolithic versus data mesh approach. Monolithic means centralized, and data mesh, it has the decentralized approach. Here in this diagram we can see any domain, suppose domain A and domain B. If suppose a business is requiring some report from HR domain and sales domain, so the centralized from the centralized warehouse, the data were present and they were extracted and analysis was done and report was created and the business was using. And there in the central monolithic data warehouses, that there was a central data team and data engineers were there. Coming here in database architecture, each department or each domain is the owner of the data and they are called as the product owner, and they have, each domain has their engineers, each domain they treat their data as their product and they create the report. And any business, suppose any business they require report, they will approach that particular domain. They will not visit any centralized approach. They will extract report from the different domains, from whichever domain they want the report from. Moving ahead, there are four core data mesh principles. So first is domain ownership, second is data as a product, third self-serve data infrastructure as a platform, fourth is federated computational governance. So what is data ownership? Here domain teams are responsible for collecting, transforming and providing data related to or created by their business functions. Instead of domain data flowing from data sources into a central data platform, a specific team hosts and serves its datasets in an easily consumable way. That means each department or each, suppose sales department is the owner of the sales data, HR department has their own data, and they are the data owners. Coming to data as a product. For data, for a database implementation to be successful, every domain team needs to apply product thinking to the data sets they provide. They must consider their data assets as their products and the rest of the organization's business and data teams as their customers. Suppose the HR team is responsible, the HR team, they regard their data as a product, but it can be consumed by other departments. So other departments and the business, here is the consumer, and they are the specific domain is the um, product owner. Coming to self-serve data infrastructure as a platform. In the distributed data architecture, it requires every domain to set up its own data pipeline to clean, filter, and load its own data products. A database introduces the concept of a self-serve data platform to avoid duplication of efforts. So data engineers are set up here. So data engineers set up technology so that all the business units can process and store their data. Self-serve infrastructure thus allows a division of responsibility among all the departments or all the domains. So data engineering teams manage the technology while business teams manage the data. So coming to the fourth point is federated data governance. As we have learned from Sir, so here comes the data governance. It is like database architecture implements security as a shared responsibility within the organization. Here, that means there are some global standards and policies that we applied across the domains. At the same time, this decentralized data architecture allows a large degree of autonomy on the standards and policy implementation within the same domain, within the domains. Going ahead, so here comes database architecture. As we discuss the four principles, here we can say the architecture of database. Here comes the federated governance, which is which they said the global standards, and all the domains have to, when they are managing their own data, they have to follow standard rules and security rules and rules and governance they have to follow. And there are also in the federated governance team, there are also auditors who audit the different domains. Are they performing according to the standards or not? Are they following the rules or not? They perform the audits among the different domains. So here comes the domain. The first point, like the domain, each domain has their own data. So here comes the domain. Suppose this is the middle one is domain A, the small one is domain B, and here the up one is domain C. So here data can be exchanged. Suppose domain A, so we can see domain A, they treat their data as a product. What happened? When there is an operation, that operational data got ingested, and there is an analysis team in each domain. The analysis team performs analysis, then they treat their data as a product, and after performing analysis, they also publish a data as a contract. So data as a contract, whatever they published can be used by other domains. Whenever other domains need data from different departments, they can use the other domain's data contract. So there is exchange of data. Suppose there are five departments, they have interoperability of data, but according to some rules and regulations. So coming here also, we can see the self-serve data infrastructure down here. In self-serve data infrastructure, there are a set of engineers. There are a set of engineers who actually help the teams, who helps the domain teams, business teams, to provide the technological support in the data interoperability or data management, whatever technological support they require. This is being provided by the self-serve data infrastructure. So there is also enabling team. So enabling team also helps across the organization to all the domains. So moving ahead, The key advantages of data mesh. So we have democratic data processing, increased flexibility, cost efficiency, improved data discovery, strengthened security and compliance. Coming to democratic data processing, a data mesh transfers data control to domain experts who create meaningful data products within the decentralized governance framework. Data consumers also request access to the data products and seek approvals or changes directly from data owners. As a result, everyone gets faster access to relevant data and faster access improves business agility. Coming to the next one, increased flexibility. In centralized data infrastructure, it is more complex and requires collaboration to maintain and modify. Here in data mesh approach, the technical implementation of the central system to the business domains, this removes the central data pipelines and reduces operational bottlenecks and technical strains on the system. Cost efficiency. Distributed data architecture moves away from batch processing, instead promoting real-time data streaming adoption. You improve visibility into resource allocation, storage cost, resulting in better budgeting and reduced cost. Coming to the fourth point, improve data discovery. A data mesh model prevents data silos from forming around central engineering teams. It reduces the risk of data assets getting locked within different business domain systems. Instead, the central data management framework governs and records the data available in the organization. For example, domain teams automatically register the data in a central registry. Then strengthen security compliance. Data mesh architecture enforce data security policies both within and between the domains. They provide centralized monitoring and auditing of the data sharing process. For example, you can enforce log and trace data requirements on all domains. Your auditors can observe the usage and frequency of the data. So moving on, coming to the conclusion, we live in times where cloud computing and digital transformation have become the norm of the organizations to thrive. The amount and complexity of data immersed in such an environment will also continue to grow exponentially. If data has to keep pace with business, conventional monolithic architectures for data storage, processing, and governance won't cut it. Instead, organizations must decentralize the data ecosystem using architectures like data mesh and think of data as a product, the most important product within their enterprise. However, decentralization doesn't mean isolation. So all the data domains should be interconnected using the unified data platform like Atlan that simplifies discovery, enables cross-domain query with a visual query builder, ensures granular access control, facilitates global governance. So here we ended by concluding this. Thank you all of you.